Hello, my name is Mohammed Jida, and right here I will demonstrate for you the effect of different geometries on the effect of spinning bodies on this gyroscope I built over here. To start off first, let me state my assumptions. The three objects, which is a square, rectangular rod, and a circular disc, they're all uniform. And from the problem statement, they are initially at rest at the Earth's inertial reference frame. No air drag, and the contact between the axles, which is over here, these are assumed to be frictionless. Now, the point of this experiment or demonstration is to show that these different geometries will spin different arbitrarily with respect to the Earth's inertial reference frame. Alright, let me show you my prototype over here. So you can see the inner frame can rotate freely. The outer frame, we're going to assume that it is fixed. And these are frictionless, assumed to be frictionless with respect to each other. Now, let's see the effect of the circular disc. First, I will demonstrate the circular disc with a little angular velocity over here, spin angular velocity. We will see what happens. The arrow is facing the camera. And here we see a very small deflection from the starting point. Let's give it another twist. And again, we see this is very uniform. Stop. And here I have the square over here. Let's give it a little spin. Arrow facing the camera again. And let's give it a little spin and see what happens. Just a small change, a very slight deflection from where it was. Let's do it again. Sorry. Let's do it again. And we see just a very small deflection. Okay, and here the last object is the rectangular rod. Okay, and it's you can see the arrow over. Let's do it this way. You can see the arrow from this side over here, facing the camera. And now let's give it a little spin. See what happens. So what happened is there's a big shift from the arrow going straight from the camera to the arrow being on the other side over here. So we can see that the rectangular rod did spin arbitrarily fast in the Earth's inertial reference frame. And this is mainly because of the moment of inertia, which I will prove soon. Here's an example of a diagram I drew before I built the prototype. And next is the assumptions that I stated at the beginning of the video for this problem. Now, for the circle and square, moments of inertia of a circle is always equal in any direction since the radius is always constant. For a square, the length is equal to the width, so also Ix will always equal to Iy. Now, for a rectangular rod, the length is not equal to the width, so this will be the main issue why the rod was able to spin arbitrarily to the Earth's inertial frame. And this will be shown with this equation over here, which says that the angular frequency of precession is equal to the torque over the spin angular momentum, where the spin angular momentum is equal to the moment of inertia multiplied by the spin angular frequency. Here we assume that the torque is constant and the spin angular frequency is constant. So what really the angular frequency of precession is affected by is the moment of inertia. And since the moment of inertia of a rod changes from the x direction to the y direction, then this proves why that the rod will spin arbitrarily to the Earth's reference frame, and the circle and the square will not. Thank you for watching, and yep.